Here, my topic is design and implementation of lexical analyzer and parser for mini etc language. Here, the first level one identifier recognition. This program checks whether the given identifier is valid or invalid using regular expression. A valid identifier must start with a letter and contain a letters and digits. If the identifier follows the rule, it prints valid identifier, otherwise it prints invalid identifier. Here are the examples. Total one, that is the valid identifier. If I give 1x, that is invalid identifier. Next, the code. Here, first code is Python import RE, imports the RE model. RE means regular expression. It is used for pattern matching. Here, the identifier is equal to input. Enter the identifier. Takes the identifier input from user. Stores the input in variable identifier. In plain text, that is x or 1x. If this line checks whether the identifier is valid. Explains of regular expression. Here the valid examples: plain text x total 1 sum 2. Invalid examples are 1x a b c a dollar b. Next, print valid in identifier executes if identifier follows all rules. Else, print invalid identifier executes if identifier is invalid. Next, level 2, that is lexical analyzer. This program implements a lexical analyzer for mini etc language. The lexical analyzer converts source code into tokens such as keywords, identifier, numbers, operators, and delimiters. It reads the program and identify each token type using conditions and regular expressions. Here the example: begin use keyword, x use identifier, 10 the number equals to, that is operator. Next, the code. Lexical analyzer Python import RE imports regular expression module Python. Keywords is equal to begin and int print. Stores mini etc keywords Python. Operators is equal to plus minus star slash equals. Delimiters are stores delimiters Python program begin int x is equal to 10 print x and end stores mini etc source program. Next, split source code into words and symbols. Tokens are generated in plain text. Begin int x equals to 10 for a words in words. Loop through each token. Keyword check Python. If word in keywords, print keyword. Checks whether the token is keyword. In plain text, begin int. Operator check Python. Elif word in operators. Check operators like plain text, plus, minus equals to. Next, level 3. Level 3 is lexical analyzer and parser. This program implements both lexical analyzer and parser. First, the lexical analyzer generates tokens from the source program. Then the parser checks whether the program follows the grammar rules of mini etc language. If the syntax is correct, it prints program is syntactically correct. Otherwise, it prints syntax error. A valid program synthetically correct, invalid identifier like 1x syntax error. Here the level 3 code. First, tokens, it creates empty token list. Lexer function definition lexer program defines lexical analyzer function Python words is equal to re dot find all. Splits program into tokens, token storage. Next, tokens dot append keyword word stores token into tuple format. Example like plain text VR, keyword begin, source program, Python program begin int x is equal to 10 print x, stores mini etc program calling ledger Python, ledger program executes ledger analyzer, display tokens, Python for t in tokens print t, display all generated tokens, parser check, Python if tokens 0 or 1 begin and end tokens -1 1 end. First token is begin, last token is end. If true, Python print program is syntactically correct. Otherwise, Python print syntax error. Valid output. Plain text program is syntactically correct. Invalid output. Uh, Plain text begin int 1x x is equal to 10 and output is syntax error. The ನಾನು ಸ್ಟಾಪ್ ಮಾಡೋದು ಮುಗಿಸ್ತಾ ಆಯ್ತು ಬಾಯಿ ಸ್ಪೆಕ್ಟಕಲ್